Okay, so what happens in this kind of an example, you always have different types of solutes and solvents mixing with each other, right? And second show you. Next is this separating and purifying of substances, or shall we go to solutions? Okay, we often think of solutions as an idea of a solution. Normally, what happens is whenever we say solution, we always imply a solution to a given problem. It may be a mathematical problem, it may be a practical problem, and yeah, of course, those are solutions to a constructed problem or a research problem. What could be a solution? After researching about something, you find out what are the plus points or negative points and what could be your conclusion. Okay, so that kind of a solution does not apply in chemistry. When we say solution, it's a mixture of various types of substances, invisible, or the bridge between each substance is not seen. Okay, that's what they're explaining. Less obvious, perhaps quite common, are solutions of one liquid in another. Say for example, you have say a mixture of lime juice in water. Clearest example, mix it up, finally you have a lime solution in water, or lime solution, just keep it as a lime aqueous solution. Aqueous solution of various other substances other than lime, any other chemical forms an aqueous solution, okay, in water. Solvent is always water. Okay, depends on what type of water you're using. Either you're using impure water, that is normal water that you drink, or you can use distilled water, pure water, simple. Alcohol and water are completely miscible. They make a solution. Miscible is nothing but they are mixable, meaning to say they complement each other rather than contradict each other. They don't form an emulsion. Where two different liquids that do not mix generally form an emulsion when under certain shaking, you shake it like water in oil and oil in water. Okay? Finally, you find little circles inside that glass of yours. Alloys are similar mixture of metals. So same way, even given geologic pressure or time, the geology of the earth, geology is pressure and time basically. Okay, so you have different layers forming, and there is a lot of pressure on a particular surface, and if you have minerals or metals present in it, and you have the heat from the core also rising up to the surface of the earth, sometimes these metals, okay, present in volcanoes, they shoot off from the volcanoes and they form magmatic rocks. Okay, these magmatic rocks can contain alloys also present in it. So that is another example of what alloys are. Similar mixture of metals, maybe iron 3 oxides of iron or something like that. Though we do not usually call them solutions. In that case, solutions, you cannot nomenclature them solutions. Okay, though it is the same. Okay, they are made by mixing the liquid metals together. Best mixer is the volcanoes and fission, fishes or cracks in the leading up to the Earth's surface. Okay, they are made, okay fine, before solidifying into an alloy. Supposing you have liquid steel, you have liquid iron, mix both of them, churn both of them, and let them cool down. Let them come to a freezing point, and from that freezing point, it changes its state into solid. Okay, and then you get an alloy over there. Separating and purifying substances. So when it comes to separating and purifying substances, there's always a chemical engineering involved in it, right? To make sense of the material world around us, we develop methods for physical separation, the many and varied mixtures that we come across. Physical separation or purifying of various mixtures that we come across, because everything has its own purpose. Now, for example, I'll give you can't put simple cement on this roof. You need a mixture of gravel, you need a mixture of water, sand and cement to form something much more harder and which will have more binding. The property of binding will be greater than the property of ordinary cement that binds things together. That is concrete, reinforced concrete cement. Okay, or concrete. Can't call it cement again. Cement. It is a mixture of various other substances in different ratios. Okay, same way this is all. In the same way this also. Okay. Being able to purify and identify the substances present in these mixtures not only satisfies our curiosity, but it is crucial for our well-being and health. As the textbook always says, that everything you see around you is a mixture. It is always impure. You can't call it impure, but you can say it is a mixture of various substances. What we are doing is, certain substances in its pure form is useful for us, certain substances in its solution is useful for us, and certain alloys also are useful for us. For example, we don't have plain tin roof, we have something called asbestos. Now, if you're going to use an asbestos sheet, what happens is, it's going to produce a negative chemical reaction into your body, and you may also even get sick under asbestos thing. Next, you have these black slabs that are used for flooring, black granite or something. So maybe the reason why people fall sick is because of the chemical reaction or the biochemical reaction that takes place between your foot and the mineral present over there. Because black granite is always not black granite, it will have some kind of mixture of other elements present in it. Okay, so therefore what happens is, naturally you sweat at your feet. Underneath your feet also there is sweat cells that produce, excrete extra salt and water from your body, right? So you're walking around barefoot in your house, there should be some kind of a reaction that is taking place at even room temperature also. And that also, will block your pores underneath your feet. And that causes, the sweat to be, foot ulcers. You can get foot ulcers also like that. Yeah, the shortest and sweetest example is a foot ulcer. Fine. Coming back to the point, there is a range of physical techniques available to make the necessary separation. They all depend in some way or on a difference in the physical properties of the substance in the mixture. The most useful separation method for a particular mixture depends on the type of mixture and the substance in the mixture we are most interested in. I'll give you another example of separation technique. Liquid chromatography. Solution, in that a black ink or a mixture of ink which looks black in color, and when you drop it in water, as it sinks to the bottom, you will have at different layers of water, you will get different colors, separating from each other, correct? And the application of liquid and gas chromatography is used in forensic science and investigative purposes, used by the police and the defense who are involved in investigating crimes and all this. Okay, so we will stop from here. Anyways, what my point is, as a researcher, you need to be independent and have some form of income. And I'm teaching my student Arnav, I call him Arnav Goswami sometimes. However, say hi to the camera, Arnav. Yeah, and hopefully, fund your way through whatever you are doing. Independence of research is also very important, and yeah, you have to be independent, right? So unless you're independent, only then you can perform. You can be, you can function very well. Your research will also be smooth. Anyways, thank you very much.